Hello friends of .NET, I'm Imo Landworth and you can find me on Twitter at TerraJobst. In today's episode we're going to do line numbers because in the past we only have support for basically reporting positions in our input file, but now we actually want to report line numbers and column information. The other thing I would like to do is a major overhaul and cleanup, because in the past what we have done so far is I've done some live coding on air, and that means usually that I'm getting carried away. I don't care so much about how the thing actually works and whether all the things we have done are actually somewhat sane. And so, as we're evolving the compiler, every once in a while when I read the code base, I'm finding plenty of areas that I can improve. So I have a bunch of notes on my site that will guide us through this process. So yeah, I think without further ado, let's just jump right into the coding portion. So before we do that, oh, holy cow, let me first enable my, much better. This is how the morning should feel. Not quite as bright. Coffee. So I have, again, two PRs. The first one I'm actually really excited about from Aniel, which will allow us to see our test results on VSTS. So it's one of the first things I would like to merge. And apparently the way this works is that there's an XUnit test logger which allow us to, with .NET Test, to write the test results into a log file, and then the only thing we seem to have to do in order to get it onto the dashboard here is you have to publish the test results, which is basically just uploading the XML file to the VSTS backend side, and then things should work in principle. In fact, we should be able to see this here. If I actually go here, which has our test result run. Good morning, Frank. Wow, that is loading super fast today. Oh, look at this. There's a test tab now. Oh my god, look at this. See, no test failures. That is amazing. Very cool. All right, let's merge this guy. Perfect. And of course, an obligatory typo fix. I hope this thing in our compiler project is more or less a crowdsourcing type checker. So, what do we have here? So yeah, I seem to have messed up write type instead of write type. Yup, that seems within the normal vicinity of me when I'm typing on screen. Sweet. Then let's get these guys in. Let's create our branch for today, episode 5, line numbers and cleanup. So I don't think I can create the PR right away. Yes, I don't think I can. So yeah, thanks William for the typo fix. All right, I think we should start with the cleanup in the Lexer. So let's do this. So one of the things I would like to do here in the Lexer is, if you remember the code that I have written here, it's a bit of a, let's just say, maybe not quite that big. Probably want to run restore. Yep. Yeah, I don't want to update right now. It's always the best point in time to update is when you're live streaming or when you're about to do a demo. I remember there was some conference, I think MVP Summit, where I upgraded my VS right before. Spectacular experience. I was in some dogfooding build of VS and nothing worked for an hour. Alright, so basically what I have planned today here is, so when you look at the Lexer method, right, there's a lot of stuff happening here and it seems all over the place. Right? We have some if checks here, where we return our enter file token. Then we have a bunch of if processing here. Then we have a bunch of switch statements here. And the whole creation process of the tokens, I don't like how this looks like. And in other parsers I've written this slightly differently. So I think the very first thing I would like to do is getting rid of all these new statements and instead having a centralized spot at the very bottom where we return our syntax token. So basically what I want to do is I want to say position is something that is maintained as state. Start is also maintained as a field. So in fact, let's just say this thing is read only and goes here. This is our position in the text. And then we will have syntax kind for the token. We will have private int start for the token as well. So these are our information about the token. And then we probably also want private string, not string actually, object value, which will hold the value for the token. So basically these guys are populated by the root method or by any other nested methods. So the first thing we want to do here is we want to say we don't want to have this if check here. Instead, I'll just move this down here and replace this with this. Because as you remember, we said when we are outside of the bounds, we return this guy here. So there's no point in doing the bounds check here. And I can delete this whole stuff here, move this down here, and now it's somewhat uniform. The next thing I want to do is I want to say, so the next thing I want to do is I want to probably say, instead of doing this, we say start equals position. And I get rid of start. Maybe not that one. Okay, this is the problem with just do string-based matching, but good enough. All right, stuff compiles hopefully. Yeah, kind is never used, I know that. All right, so I think that one looks reasonable. Yeah, then the one thing I want to do here is, instead of doing all of this, yeah, what is easier? Let's do this first maybe. So kind in this case is number token. And we can say value equals value. Yeah, and when we start, we should say kind equals syntax kind bad token. And we should say value equals null, so that we reset things properly. And then I think I'm almost there. So instead of doing this now, we say, what would be the best way to do this? You know what? Screw this, we extract a method. And where does this guy go? Here. So we say this guy returns void. Don't want to return the text. And then we say this is read number token. All right, and then we say var text equals syntax facts get text. So the idea here is I want to centralize this whole code down there. In fact, let me do this. Let me first do the control flow here so we get an idea of what is in my head. So this is what I currently think the control flow will be, and then we say in the default case we do this. I guess this break is unreachable. We get this guy out, and then I think things get somewhat consistent. So we say now if the text, so the syntax facts do not have a text for our kind. Remember that this getText method basically returns the fixed text that is associated with the token. So if this thing is null, that means it's basically dynamic text. In which case we say text is text substring for our start and our length. Length at this point is obviously position minus start. Yeah, or is it? I think it should be, but this is after we incremented, right? So when we reach this point, we process the token. So yes, this should be the correct length. And then we can return this text, and then this one is no longer needed. All right, so far so good. So now we have obviously a bunch of duplicated stuff here. So let me extract these guys first. So in this case, kind would be whitespace token. We don't have to remember the text anymore. Then we can extract this guy and say read whitespace. I would say this is read identifier or keyword. Now let's order these guys in some sensible fashion. For some definition of sensible. All right, this is getting somewhere. Now these guys here are now all even simpler. So instead of doing all of those, we just say kind equals syntax kind. We can pretty much ignore all of those. The only thing I have to do here is I have to say position plus plus break, which in these guys here is not correct. We already have a position increment. Now this is roughly where I want it to be. So this is here something where we can simplify it a little bit, and we can say we definitely want to consume this guy, and then we can just say if current is this guy, and then let's have the shorter if first, and then we can make it even simpler. Well, this is weird. I want to add the braces here again because I don't like it when one of the branches has braces but the other one does not. That reads weird. And then same thing here, we increment the position for sure. Here we do it one more time. Get the break out of the if and invert this guy. No. What? No. What did I do? Invert if, that's what I want. All right, so this reads somewhat sane. Now instead of doing these ifs here, I will simplify the switch as well and move the whole thing into the default. Which now has a much nicer control flow. And then we can all of this guy up again. And now we have more or less a single switch statement that gets us going. Now there's a few more things we can optimize here. So instead of doing this silly check there, we can just say numbers, we know what they are. All right. 1, 2, 3, 4. I can say 5, 6, 7, 8, 9. Then we go into this case. What exactly is the problem right now here? Yeah. Nope. Really? What am I missing? Oh, the else, yes. Funny error reporting, but yes. All right, so then the nice thing of this one is now that it's much faster for the Lexer to dispatch, right? Because we don't do an if check, we just directly jump to the corresponding case label. And we could do the same thing for white spaces as well. We could just say, you know, the most common white spaces that we have are probably going to be these guys. You know, space, tab, line feed, and of course, carriage return. And we could do the same thing for letters, but that's kind of, I'm not feeling the vibe to add 26 times 2, 52, yeah, basically 52 different values. But the point is here, why do we do this still here? Because, well, we're Unicode enabled, or at least it's nice to be Unicode enabled, so we still want to check for the Unicode white space classification, and so we still want to do the white space check here. It just means that in the very common case, we don't have to go down through this path here. And probably, now that I said it, we probably want to have it like this. So this letter is probably the more common case than white space at this point, because we handled the most common white spaces already here. Yeah, so kind is never used. That seems hard to believe. Oh, that makes more sense. Okay. Reading the error output is also an art in and of itself, as it seems. All right, so the only other thing that I don't think we ever assign the value, do we? Oh, no, we do. All right, we assign the value here. And then for identifier or keyword, same thing. This guy goes there. So the only inefficiency that we currently have realistically is that we, in our we identify our keyword, we do the substring operation here, and then arguably we are doing it again here. But the nice thing is we don't necessarily do it twice, because this substring operation here will not actually do anything, because we basically ask for the fixed text, which if it's a keyword, we'll just basically say, yep, I already know what the text is. We don't do the substring again for keywords. We only do the substring again for identifiers. And strictly speaking, this substring here is the actual text from the input, versus this one is the substring from the processing. So you could imagine if our keywords, so if we would support things like this, like C# has this, where you can say var at if equals false, right? Then this is an identifier because it's basically escaped. So in this case, this would be our text, versus this would be the value of the identifier, if you will. So if we were to support this, then this area here, this substring here, would be, some string builder result rather than just getting the raw input. So that's the only thing that we want to maybe keep in mind as a future optimization. Other than that, it looks like it might actually work. So let's try to run the test and see what happens. Oh yeah, it looks fantastic. All right, let's think about what's happening here. We say start position. This position. kind is bad token, value is this. We increment the position. Which seems right. So we go here, we say, let's say this is 0, this is 2. So in the common case, I think it might be off by 1 here. Let's see whether this fixes our problem. Nope. So this is one of those cases where it might be easier to just run a single test. So what ends up happening here? We say, okay, that's interesting. So honestly, I have no idea how I can run a single test within the IDE. We probably want to cheat for now. I know it is super lame, but hey, it gets the job done. So these are our simple test cases, and they should work, right? So Lexer Lexus token, white space token. So we say expected, actual. Yeah, so clearly we are off by 1, but it seems the other way around. Yep, that is now the other way around. What have I done? See, if this test output here wouldn't be so hard to read, we might actually have a chance of debugging it. It's almost like so for numbers, we are definitely. So the idea is, in general, when we lex or when we call our read methods, we want to be one past the token. Right? Well, the first thing I want to do here is, instead of doing next, because that's the other thing that annoyed me, we do this one and we get rid of our next method, because we don't really have an encapsulated read pointer anyway, so we might as well just not not do next. So in the whitespace part, I think we do increment the position. And we always remember start to be the current position. We start with a bad token, we say value is now. You know what? How hard can it be? So instead of doing this, that's why we have debuggers, right? We don't have to make our lives more miserable than it needs to be. All right, single identifier. All right. So what is length? Length is 1. Text is A. That seems reasonable. Now we say length equals 2. Clearly that's not reasonable. So clearly this would have been the correct answer. So that means if I have a single token, A, unhandled exception. Now that's funny. So let's try this again. A. So we said already here, this works the way we want to. So we say text equals null. That makes sense. So we say now give me the text for start, length, which is this one. So now we say kind, start, text, and values null. That seems all reasonable. Alright. Now we go in here. So start is 1, kind is bad token. You say end of file token. That might be the problem. Booyah. That is the problem. Our end of file token should not increment the position anymore. Does that fix my problem? Yes. Yes, it does fix my problem. All right. See, friends, you should always debug. Because turns out it's so easy to get things wrong. All right. Clearly this does not fix all problems. Expected 3, actual 2. Well, so we have failed 63. So what do the failed ones have in common? So bank token, white space, followed by equals. All right, let's see what ends up happening when I do that. Unexpected token, bang equals token. I believe that. So bang equals token would be increment the position. Yes, we messed up the check here. This is when you do too many things at once. Here we go. Normally I'd say that was easy, but that does not quite hold. But I think I'm quite happy with where we are now in terms of how the structure of the Lexer is now. Adding tokens now is not quite as bad as it used to be. It's a bit more straightforward. to read, in my opinion, and also slightly more efficient. All right, so now let's just see. Okay, we move the diagnostic back up, move the next method, change the way the Lexer works. Yep, did all of this. That looks all reasonable. Let's get one more pass over the order in which things happen here, but this looks nice. So text diagnostics, yeah, I think I want it like this. All right. So we say cleanup Lexer. So now that we actually have a commit, we should be able to create our pull request. Call this episode 5. Yeah, so there's a few more things in the Lexer tests that I didn't like. So let's go to the Lexer test. So what we have done here is that we construct here our array of tokens that we want to assert. And in order to do that, what we probably want is we want to separate this thing into two categories. We have fixed tokens. And what we do is we say enum.get values for type of syntax kind. And then we can say we want the ones where, no, actually select yeah, you can probably just do make our lives a little bit easier. Cast to syntax kind, and then we can say what we want is we want the kind, and then the syntax factory syntax facts get text for kind, and then we say where, we say this is kind, this is text, and then we say where text is not null. This allows us to get rid of all of those guys here. And then we say, instead of saying this, we say this is var dynamic tokens, these guys, and then we say return fixed tokens concat dynamic tokens. Nice. Out of curiosity, how many tests did we run here? $577. Still run 577. Okay, that leads me to believe that we didn't mess that one up. But it now means if I add new tokens, I only have to make sure that my syntax facts are updated properly, and then I don't have to do this again here. All right, so then the only other thing, because I'm paranoid, I want to add another test here that verifies that we actually test all token kinds. And in this case, this is actually a fact. So same trick as here. Let's get all the token kinds that we have. We want the ones where this guy ends with keyword or token. And we call this token kinds. Right? Then we want to make sure that, okay, these are all the token kinds that we have. Maybe we should say, oops, to list or something. Then we say the tested token kinds are basically the one that we will, so it's basically get tokens and get separators concatenated, right? So tested token kinds are get tokens, concat, get separators. And then I guess, technically speaking, because we return tuples there, it's t kind. Actually, we don't need that. Instead of doing this, now we say, okay, var token kind or untested token kinds is new sorted set syntax kind for these guys. And then we say untested token kinds. This is the tricky thing, except with is the one we want because that's the one that is returning void. Yep. And then we can say is empty or empty, empty untested token kinds. Oh yeah, so a bad token and end of file token we don't test, which makes sense. Remove yeah, those are the two ones that we can't really test in a straightforward fashion. Or there's also no point in testing them, I would argue. Nice. And that now means if I add a new syntax token, and let's say the comma token, I should immediately fail. Nice. All right. So this way, if we add something to our tester, to our Lexer, Actually, let me do these as two different commits. And say this is simplify or use syntax facts get text in Lexer test. And then we add one more, which is add test to verify we test all token kinds. Nice. All right, doesn't seem like we have any more questions. All right, one thing that I also remember is one of the first PRs that I got was fixing a kind in the boundary, because our evaluator doesn't actually use a switch statement. So one of the first things I want to do is move this thing into separate methods to have the same flow as we have everywhere else. So instead of doing this, we say extract method and say this is evaluate literal expression. We say this is, no, don't do that. Do the other one, which is evaluate variable expression. Evaluate assignment expression. And then this is evaluate unary expression. Evaluate binary expression. And it would have been substantially easier if I would have done it the other way around, so I don't have to shuffle the methods around. But hey, it's surely not the worst thing I did today. Evaluate a variable expression. Yeah, and then instead of doing these guys here, we do the casts right here. Note. We can get rid of this guy. And get rid of this guy. Get rid of this guy. Almost. And then instead of doing this, we say node kind equals bound node kind literal expression. So let's do this instead. Nice. Now we have a sensible switch statement here. And now everything is in an order that I want. Well, yeah, so Thank is asking, why don't we just use virtual methods for this? Because I really don't want the evaluate method on the bound node tree. Because in the end, first of all, we don't want an evaluator in the long run. This is more like a temporary thing anyways. And then more importantly, as we're expanding what we do, there will be more and more stuff we want to do on our nodes. So we generally have to walk the bound tree anyway. So I probably eventually will have a bound node tree rewriter where effectively the return values here will be new bound nodes. And yes, you can do them as well as a visitor pattern where you basically have a visit method as a virtual method. But I don't know, I find these switch statements much easier to deal with than thinking about, you know, 2-pass virtual method dispatch, because all it really does, it just adds a virtual method call somewhere and you get rid of a cast somewhere, but in the end it does the same thing. I just find it easier to understand. Anyway, so I think this is what I wanted to do with this guy. Let's first run our tests just to make sure we didn't break anything. Not that I would break anything today. Let's say this was replace is checks with switch in evaluator. Yay, done. All right, now let's talk about our parser. There's, I think, a few things that might be worthwhile doing. Yeah, this is one thing. What else? I generally like the structure of the parser. Oh yeah, here's the same thing. I think I want actually methods for that. So before we do this, let's say match token. So why do I do these guys? Well, why do I match token now here? Because I already know I'm standing on one. Well, because I want to extract this into a method. And I want to call this parse identifier token. And so when I reuse the method, well, then I really want to make sure that, actually no, I don't want to call this parse identifier method. It's a parse name expression. So when I reuse this method call from somebody else, then, well, this guy has to ensure that it actually is standing on an identifier right now. So that's why I generally will have these guys in here. So we say this is parse boolean literal. And then this guy is, what is it? Parse parenthesized expression. And then this guy would be parse number literal. And then generally speaking, I think we want it the other way around. We generally want to insert an identifier rather than a number token. That seems much more logical. So we say case syntax kind identifier token. Of course, this one is not strictly speaking required. It just makes it easier to see what default is supposed to do. Well, the default is just basically going here. Seems somewhat sensible. All right, so match token, we don't have one here. So we say var is true. And they say current kind is this. Then we say if it's true, then we say match token syntax kind true keyword. Otherwise, it's the false keyword. And then the value is just is true. Same thing happened here. Match token, open parenthesis token. Yeah, I think that is also somewhat nicer. Yeah, I think that's all I wanted here as well. Let's make sure that we have that guy going as well. Seems this way. All right, so one other thing that I want to do. So I've done this in a few places where I'm using like a poor man's version of something that is supposed to be immutable, but we really are returning it as an I read only something. So let's just search for I read only here, for example. So it's really an array, but we return it as an I read only list. That's generally not a good idea for public API because anybody can just downcast this guy to the actual array and then modify data. And this can happen by accident when you just pass it around and somebody does a try cast or whatever. And so in general, I would like to replace them with things that are actually truly immutable. And so we have a collection type for this. So let me just add the package for that, .NET add package system collections.immutable. Yeah, and then as I learned the hard way, so now same search again, read only. Perfect. So now instead of doing this, we say immutable array, and we also take an immutable array. Then we don't have to do this. We can just store it as it is. Same thing here. Take an immutable array of this guy, and we can save us this. And of course now when I build, I will probably find out that stuff doesn't work anymore. So diagnostics is to immutable array instead. Yep. And then same thing happened here. Instead of doing this, we just say to immutable array. And then instead of doing this, we say it's immutable array of diagnostic empty, and it's just a field. Nice. And then honestly, same thing here as well. So any other uses of toArray? No, not really. All right. Immutability. It's a thing. It's actually super nice. If you've never used immutable collections, I highly encourage you to give them a shot. They are actually awesome. And yes, I might be biased because I worked on them, but I've also used them a lot over the years, and I'm actually quite happy with the usability of it too. Use immutable array. All right, now we are working our way slowly up to the fun part. So by fun part, I mean you can see me struggle writing a binary search. So what I want to do is, first, before we go down that path, there's a little bit of busy work that I have brought upon myself that is super unnecessary, as it turns out. So we have all these get children methods here, right? And realistically, given that we don't really care about efficiency right now, and I mean, this is not a hallmark of efficiency anyway, given that we instantiate a state machine here and like walk the thing, you might as well just go all the way and say, you know what? I know how we do this. We say var properties is get type, get properties. We say binding flags public and binding flags instance. And then we say for each var property in properties. And then we say if property, now if, I can remember property dot property type, I think. Yeah, it's the other way around. Type of syntax node is assignable from this guy. In other words, can I convert, like, is this property, is this type here something that I can convert to syntax node? Then we say yield return syntax node for property, nope, property dot get value, this. Else Jesus, clipboard is a thing. Then we do the same thing here, but then we say for each var child in, well, let's say var values equals it's I enumerable of syntax node in values, or let's call this children. yield return child. Well, let's get rid of these overrides here. That was a little bit much with Control W. Right, so now the nice thing is we just walk all the properties of our node and then say if it's a syntax node, return this guy. If it's an enumerable of syntax node, then just walk them and return them individually. And the reason I'm not doing it the other way around by evaluating the property first is to just make it a little bit more efficient and avoid some of the downfalls when you do eager evaluation of things and end up in recursing in parts you're not supposed to recurse into. Does that make sense to everyone? Nobody seems to have questions, so I suppose that either means I completely lost you or everybody seems to silently nod in agreement. Yeah, this is also one of the areas of the compilers where metaprogramming would be nice, because you, instead of doing this with reflection, what you really want is you just want to return, basically define the getChildren method automatically, so you don't have to write the tedious code yourself. Unfortunately, we don't have the facility to do that easily. The way the C# team has solved this is by just having a giant XML file and just generating the entire node hierarchy with a command line tool. That also works. Simplify, or I should say make syntax node get children non-virtual. All right. So one other thing, so William is asking, how can we know that the yield return sequence is returning, or that the reflection version is returning the same order as the yield return version does? That is a great question, William, and the answer for that is, well, that's what you have tests for, which I just ran, I think. Maybe not. Maybe I did. Okay, our tests are passing, but like what this order here is getProperty is the way it returns the order is the order in which they are currently in metadata, and the way they quoted in metadata, I don't think that's necessarily guaranteed by the compiler. Well, I think in general the compiler has to maintain the order in the metadata format for structs because the memory layout matters. I think for classes it's the same thing. The order is the same as you write them in source code. The only tricky thing here is I'm not sure reflection guarantees that we return them in the same order. I think practically speaking we do, because we just walk the metadata. So it will work. So right now when I go to the binary expression, for example, and I declare them in a different order, you would expect our tests to fail. Yeah, and this is the So you can see by the number of failed tests, these are our binary operator tests where we assert the precedences. So yeah, the order is the order in which they are declared right now. And given that I assert the order in our tests, I have some mild confidence that I didn't mess it up. Yeah, but for production compilers, I would not, I would not rely on the order of reflection. I would probably just do exactly what we have done before for all my syntax nodes. But right now, given that we still evolve the whole thing, it's just busy work for us. So let's not do that. So the other thing we would like to have is our syntax token already has this concept of a span, right? In fact, it doesn't. Actually, it does. It has the text span here. But only syntax tokens currently have a span. But we really want is we also want arbitrary nodes to have a span. So what we can do is we can say public virtual text span span, and I will just cheat. Again, this is not super efficient, but it will work. First is get children. First span var last get children last dot span, and then we say return text span from bounds, which we don't have yet, first dot start. Fine. First dot start and last dot end. Let's say return new text span var length. That would be end minus start. It's a handy helper to just be able to just construct a text span just from the bounds rather than start and length. Is this actually correct? I believe it is. Yes, it is. And now the tricky thing is on the token. We need to override this guy and say, in our case, we just return our own range. So that means for anything that is a node, fundamentally, the node has to have as a child either a token or other nodes. So I can just say, yep, just give me my first and my last token, or my first or last node, and then just construct the span over that. Right? So this way we can now say for any given artifact in the tree, we can always ask what the span is in the input file, which is quite handy. All right. This is something where we could maybe think about whether we can test that. What would be a good way to test that? Yeah, there's not a super straightforward way for me to test the spans. Yeah. Let's think about this some other time. But add syntax node dot span. And then I think the last one I want to take this guy here and move this to syntax node directly, because it seems generally useful to have a method like it. But Of course, we don't want to write to the console. We want to output to a text writer. And then I want the public method, public void write to, that takes a text writer. And then we just say pretty print writer this. And then while we edit, let's also override toString, public override string toString. And we just say using var writer is new string writer write to writer return writer to string. And then instead of using this guy here, let's delete this whole guy. We now say write to console out. Let's quickly run this to make sure we didn't mess it up. But I think this should work. Yep. Yeah, Jason was asking whether we could make it an extension method and what's my take on doing that. We could. I mean, there's nothing fundamentally wrong with having these kind of things as extension methods. The fundamental downside of extension methods is you just have to find another type to put them on, right? So I would have to create another type somewhere, I don't know, syntax helpers or something, or syntax extensions, right? Which we probably have eventually anyways, so it might not be bad to have that. But like core functionality like this, you know, I can go either way. Like in general, the reason why people prefer extension methods is because you can layer them differently, right? So a good example is I have a CSV document that represents effectively the same as an XML document, but in CSV form. And I have a very handy extension method that I can invoke on the CSV document that is called view in Excel. And so all it does, it uses the automation APIs from Excel to boot up Excel and then just stream the data over to Excel. Now logically, you really don't want an Excel automation API tied to an XML to a CSV document. So this is an area where you really want to have the extension method logically as at a higher layer than the CSV document. But things like here, like writing the syntax tree to an output, I'd say is logically the same layer as the syntax tree itself. So making that an extension method or not is, I guess, at this point, personal preference. What I generally like though is that like core functionality or things that I think are mainline things, I put on the type directly. Even though sometimes like this one, given that it's all static stuff, could have been extension methods. And some people also prefer this for layering so that you can make sure that your write to methods don't mess with the state. So everything that can be an extension method, people like to make extension methods. But coming from the framework standpoint, I don't like doing it for some stuff because, well, maybe in V2 I need some extra state where I'm screwing myself if I don't have access to that because I'm external to the type now. But it's something that you can think about and probably should think about. All right. All right, now let's talk about line numbers, finally. So what I want to do is I want to add a new concept. So let me actually add a new folder for this. Call this text. Yep. Good starting point. Let me move our text span into that. You know, fix a bunch of compiler errors. Bunch of busy work, but sometimes you have to do what you have to do. Yep, that looks like what I expect. Move text span to text namespace. All right, now we add a new thing here, which I will call source text. And of course I'm lazy, so let me start with this. And basically what this guy gets is a private one for now. And then we have a public factory method, public static source text from string text. The reason we have a static method here is because this one will be fairly expensive, because basically what we will do is we will parse the text here. And then the idea is that this guy exposes line number information. So one of the problems that we have is currently everything is done with text directly or with strings directly, and so everything is position based. And positions are awesome because positions mean you can have a range represented by just 2 ints, and you can do computations over them. You can easily subtract them, you can easily add them, and things generally compose really well. But for error reporting, you generally don't want to report, you know, you have an error in character offset 20,562. You really want to say I have an error in line 100 at character offset 5, right? Like, or column in the line. And so the way we will do this is we will pre-process, if you will, the text and remember effectively how long the lines are, so that given the position, we can now compute the line number. So we need another representation here. So we have a public sealed class text line, which in our case will hold on to the source text line. And then it will have a text, it will have an int start, an int length, and an int length with, or length including line break, right? And that might be picky here because, but remember that lines can have mixed endings, right? You can have carriage return, you can have carriage return line feed, you can have just line feed. And of course the last line doesn't have to have a carriage return, right? The last line might be like this or like this, right? In which case the last line is empty. In this case, this is the last line and it does not have a line feed at the end. So there's no no position here. So somehow we have to remember this. And this is effectively the representation we have for that. So each line, let's actually have fields for this. Actually, that makes no sense. Let's just make them properties rather than thinking about it. And then we will just have public text span, which will be new text span for start and length. And we will have public text span, span including line break. That will be new text span for start and for length including line break. And then yeah, not quite. Sweet. So what we will now do is to say lines is parse lines for text and this. So let's create a method. No, let's create a method for this. Thank you. And it will be immutable array of text line. Yeah, I think I want that. Just not here. And this one will be static as well. All right, so how will this work? So first of all, we need a result. So we say immutable array, create builder for text line, which is basically the way we add anything to it. And then we say return result to immutable. And then we say for each var c in text var line break width is get, actually no, do a for loop. From 0 to text length. And then we say get line break width for text and I if line break length is 0. So we say var line start is 0. And we say line start is that's an interesting one. So I think we say, so the idea that I have is I want to basically walk over the text, have a method here. Let's first write this guy that basically just returns how, like if it's a line break, so if text, so let's say character is text at I, the look ahead is if I is text length, then it's, I don't know, otherwise it's text my plus 1, right? So then it can say if the current one is the carriage return and the next one is a line feed, then it's 2. Otherwise, if it's a carriage return or if it's a line feed, return 1, otherwise return 0. So in fact, I want this while true, var position equals 0, while position is less than text dot length. All this position so if position is null, in that case we just say position plus plus, else we increment the position plus our line break width, and then we say line start equals position. And we have to add the current line. So we would say result. So we say var line equals new text line. Where are we? We cannot say this. We have to say source text. Start is our line start. And then the length. So var line length is of course position minus line start, right? Var line length including line break is line length plus line break width. Let's call this add line, because we need to call this one more time here. If position is if position is larger than line start, that means you still have a line left. In which case it is right. Does that seem right to everybody? So let's move this guy into a separate file. All right. So now the fun part. So I need to write a method that, given the position, gives us back the line index. right? So very naively, we could just write a for loop that checks for each line whether the position is, whether the position is inside of our lines, inside of our line, and then return it. Otherwise, keep searching. But that is very inefficient. So what we really want to do here is a binary search. So logically, what we want to do is we want to find the line that contains the position. Yeah, that's a good point, actually. I don't do anything in this one. Good catch. So we need to pass in the builder to actually say result at line. Thanks, Benjamin. That's a good catch. All right, so now traditional binary search. The idea of a binary search is when you look at all the lines, we just go to the line in the middle, and then effectively decide whether the line is before or after our position, and then either you keep searching in the top range or in the bottom range, and you just keep recursively repeating this. So it's a much faster way to find stuff. So we say lower is 0, upper is yeah, good point. We need to store this guy too, but not like this. Upper is text length -1, and then while lower is less than or equal to upper, index is lower plus, what is it, upper minus lower divided by 2. All right. Start is now lines for index dot start. So now the question is, if the position, this is the part of a binary search is fun to get right, if position, so if start is less than position, so if start is less than position, what that means is that we can discard the lower part. So lower is upper. Well, first let's say if start equals position. No, that's the other way around. If position is start, and we're exactly on that line, start, then clearly we return that index. So if start is, so if position is larger than start, then we have to adjust the lower window to upper +1. Else we have to adjust the upper this is where I would normally draw something, but I don't have a piece of paper, which makes it somewhat harder. Yeah, the notes are not helping me here. No. What are we doing here? So yeah. All right. I think this makes more sense. So then we have to adjust let's think the other way around. We have to adjust the upper window. So we say this is index plus 1. No, index minus 1, the usual stuff. And then this is the other way around. This is lower is index plus 1. Yes. So logically what ends up happening is, so if start is larger than the position, that means we are in the lower window, which now means we set upper to where we currently are minus 1, which basically means we discard the upper window. Otherwise, that means position is, or start is less than or equal to the position. Well, it cannot be equal, but you get the point. Then it's the other way around. Then we discard the other side of the window, and then we keep going. So then eventually we either hit the exact line, in which case we just return the line, or we reach the point where lower and upper start to intersect, in which case the loop terminates. Which now means if I reach this point, that means I found the line. So lower is basically like we are on the line indicated by lower. Minus 1 because we clearly adjusted the window here. So we have to return lower minus 1. I think that's right. But we will also find out what ends up happening when we call the method. This is one of those things where debugging is much easier than trying to keep it in your head. All right, great. Now we have the source text, so let's assume it works. There's a few more functionalities that we need on the actual type. So right now we only have a way to get the line. I don't want to expose the text. Instead, what I want to do is I want to have other methods to that. Public override toString, which in our case just returns text. And then I have a new one, public string toString, that takes a start and takes a length. And that is text substring for start and length. And then we also have one that for convenience takes the text span. This way we can get things out of it. And then I think what we also want to do here is we probably want to have the same concept here on the actual text line. In which case we say text toString for span. Actually, I don't think we need one of those guys. All right, that seems somewhat reasonable. So now we have to use this guy. So instead of, so we start with the Lexer. Actually, let's start with the compilation. That might be easier. So with the syntax tree API. So we have this overload here. So instead of doing this, we are doing this one and say there's another one that says source text text. That will do that, and then we say var source text equals source text from text, and then we just say return parse with the source text. All right. From here we say the parser takes a source, takes a source text, and passes that to the Lexer. The Lexer takes a source text and then parses that down as well. All right, yeah, source text definitely. It's a few APIs we want. We want a public char this index, which is basically just returning this guy. We want a public int length, which just returns text.length. And now everything else should almost just work. Yep, instead of substring, we now say toString. And then yeah, this is actually a bug. Instead of returning the entire text, we also want to return just the text that represents the part that we weren't able to parse. Funny. And then we do the same thing here. Right? So it seems like a lot of work, right? The question is for what benefit? So right now we only have this guy here, but the other thing we would like to have is the notion of a location. So let's first just commit what we have and see what that actually even builds. It does. So and well, actually maybe not yet. Let's at least consume the API somewhere. So if we go here to our program file, when we print the diagnostic, that's a good point. Well, syntax tree. Should probably hold on to the source text. Which means we should probably also hold on to the source text. Now I can say text. Now what I want to get here is, so this is the so this is where we want to get the, well, let's say var line number equals text get line index for diagnostic span start. And then I can say character is diagnostic span start minus line number minus, well, let's say our line, that would be text dot lines line number line index, to be precise, start. Let's say line number is line index plus 1 plus 1. Right, so from the diagnostic span we subtract where the line starts and then we add 1. And then we can say here, how about we say console write line number character. Great, we crash. Of course we do. Index is 2. That's funny. How is that possible? Pum 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 pum. So let's check first what is text. Text is A plus B. That makes sense. The position is 0. Well, the lines have a single text line, A plus B. That makes sense. Lower is 0, upper is 4. What? Oh, I'm an idiot. It's not text length, it's lines. You're doing a binary search through all the lines, not through the text, dear Mr. Landworth. Yeah, that's not quite the output I had in mind. What am I doing here? Oh yeah, again, I'm an idiot. Yeah, so line 1, position 1, line 1, position 5. 1, 2, 3, 4, 5. Yeah, that seems right. Yeah, I push usually live to GitHub, but only like after it actually works. That's nice. So now let's try to cheat a little bit. What the heck? Let's do this. Git istage. Let's just commit what we currently have because it actually seems to work as far as I can tell. Yeah, let me actually. Oh, that's actually a good reset. Yeah, that makes sense. All right, git commit. Let's call this add source text. Already had it set up. Doesn't matter. All right, so now the only other thing I want to do before we leave is I want to support multiple lines in our little REPL here. So ideally, when I say IA plus and I hit enter, oh, we crashed. That's not great. That seems like still an off by one somewhere. Haha. Yeah, this is unrelated. I bet you what ended up happening here is this is an inserted token. In which case we would have to do this. Yes. So when we insert a token in the parser, so we basically had a missing token, so we inserted one. So text was null, but then we have to say fix null reference for cases where the token was inserted. Yeah, the key point here is what I want to do is I want to say if you're here, I don't want to get a parser error. I just want to keep getting input from the user until I no longer get errors from the parser or the user entered the blank line. It's a typical behavior that REPLs have. So let's think out how we would do this because it's not that hard. We would just say var, let's say text builder is new string builder, right? It would say if there's anything already in there, or I should say if there's nothing in there, we do this. Otherwise, we print this guy here as a sign that it's a continuation. So if text builder length is 0, then we do our special handling for the special commands. Actually, let's do this and say var is blank. Yeah. So if is blank, then break. So text equals string, no, text builder to string. Let me guess, we're missing the using for this guy. Yep, we do. Of course, we have to say text builder append line. And then instead of doing this, we say this. Okay, if so all we want to do here now is say if syntax tree has any diagnostics, so if the line wasn't blank and we had any diagnostics, then we say continue. Okay, let's inline this guy. And then of course at this point we say text builder clear. So let's see whether this works. A plus B. Okay, that seems to have done something bad. A plus yeah, of course. So generally speaking, yes, but our diagnostics are not quite right yet. So instead of saying line substring, line, here we say input. And then here we say introduce local, and we say this is var line. And so in this case we say line start, line end, and this is sort of doing it for the input. We are doing it for the entire text document, and of course now we have to use toString instead of getText. Yeah, so the idea is that we just limit the output to the current line, or the line the diagnostic is on. Oh, there's still something fishy going on. Start is 3, length is 3. Text is A+. So the diagnostic is 3. Oh, duh. Yeah, these are the. Yeah, no, yeah. Var prefix span. I think this is easier to say. That is new. This is text span from bounds and then we say this is suffix span. And then we just say prefix. This is toString for the prefix span. If only echo type. And then error is obviously same thing, but it's for the diagnostic span. And then suffix is for the suffix span. Yep, I think it makes more sense. Probably should have launched it under the debugger, because what are the chances that it works now? All right, that's not bad. So if we say A plus B, we get variable A doesn't exist, we get variable B doesn't exist. The only thing that is mildly concerning is that you somehow collapse it into one line. Okay. Yeah, that is not right. How the heck is that possible? What are we doing wrong here? So we are saying the prefix span goes from line start to diagnostic start. The suffix span goes from the diagnostic span end to the line end. That seems reasonable. The prefix then is just the prefix, the arrow is just the diagnostic arrow, and the suffix is basically this one. Seems also very reasonable. What am I not seeing? I mean, I'm slightly over time now, but I really want to finish this part here because that seems to be the correct ending for today. Something tells me that the line starts are not right. So let's see what ends up happening here when we get here. So A plus B close. What? What do you mean unverified breakpoint? Okay. So line index is 0. Yeah. The bug is not here. The bug is not here at all. The bug is here. Append line. That seems more reasonable. Yeah, here we go. Now this is nice. All right, I think that is a nice, nice way to end. We say add support for multiple Sweet. All right, everything's building as far as I can tell. All right, so today what have we done? We have cleaned up a bunch of stuff. We have made our REPL multi-line, and we also changed our error reporting to actually include. Actually, did we change our error reporting? No, we did not. We just changed the way that the error reporting can consume the input, so you can actually get line number positions if you choose to do that. We currently do not have a good representation on our diagnostics. We will probably add some sort of location information, but that gets more interesting when we actually have multiple files. Right now we only have one file, so it's not super interesting to do. So that's something we will do in the next episode. And then I think moving forward, what I want to do is I want to add support for statements. But before we do that, I think I want to make my REPL a little bit more interesting, especially how it deals with variables. That's what we will do in the very next episode. So hopefully you enjoyed today. It was a bit more chaotic than usual, but that's what happens when you do cleanup and you have not enough coffee, I guess. All right, guys. Thanks a ton.